afternoon, everyone. Once again, thank you so much, everyone, for your time, and welcome to the Tech Horizon Executive Webinar Series, Solving Gen and AI Great Challenge. My name is Diadona. I'm representing the Ortus Club, and I will be your Master of Ceremonies for today's webinar. We are also joined by our colleague, Han, and she will be doing a live illustration of the discussion as we go, and we'll make sure to give a spotlight later for everyone to see an illustrated summary of the session. And of course, we are very lucky to have Thoughtworks for giving us the opportunity to bring everyone together for this exciting webinar today. We will be hearing more from them later, but on today's program, I would just like to touch briefly upon the agenda. As in a few minutes, we will be having a short presentation from our host, Thoughtworks, and this discussion will last approximately 1 hour, so let's make the most out of it. Just a couple of rules before we start. This session will be recorded, so should anyone want a copy afterwards, for those who are not able to make it, we will be able to share it upon request. Of course, basic virtual rule, let's make the most out of question and answer feature, and to ask the panel any question you might have. And with that, I'd like to introduce our amazing moderator for today, Prasanna, from Thoughtworks. Prasanna, take it away.
All right, thank you, Didi. Welcome, everybody, to the topic that has on everybody's mind in the world of Gen AI and LLMs these days, which is evals, LLM evals. So let's get started by introducing our wonderful panelists. On my screen, I see Aaron first. Aaron, you want to introduce yourself?
Yeah, so my name is Aaron Erickson, and I lead our efforts for AI in NVIDIA, what's called our resource governance team, where we help distribute, distribute, and make sure GPUs actually run well. You can almost think of it as like HR for GPUs.
HR for GPUs, all right. Musa, you're next on my screen.
Hi everyone, my name is Musa Parmaxis. I'm leading the AI and Data Center of Excellence in Investment Banking in UBS.
All right, Carlos.
Hi, my name is Carlos Villela, and I'm a software engineer at the same team as Aaron. We're the HR for GPUs. I like that name.
All right, Cheyenne.
Hi, I'm Cheyenne Mohanty. I am the head of AI research at Thoughtworks. So I lead all of our AI research initiatives, starting with evals.
All right. I'm Prasanna Pense. I am also at Thoughtworks. I play the role of the Global Director for AI Strategy. So I look after things like partnerships, what services and solutions we go to market with, and other things, I guess, as they come up. So I'm going to get started just by trying to define what it is that we're talking about in very, very high level terms. Simply what we're saying is that as the world puts out POCs before they can go into production, one of the things that you have to make sure, there are a number of challenges before an LLM application goes into production, but one of the challenges is, do you know if the LLM is doing what it's supposed to do? And how do you make sure it's not doing what it's not supposed to do? That's broadly the space of LLM evals. And yeah, and so with that, let's get started. So Aaron, let me ask you this question first. How do you define the problem that the industry is facing right now when they put around LLM evals when they're trying to take a POC into production?
Yeah, so I call this the demo is easy and production is hard problem. It is really extraordinarily easy to get a LLM app to look like it's doing the right thing, to generate graphs for you, to do what LLMs are really great at doing, which is confidently, state wrong things, right? Or do so in a manner that has, I like to call it great executive presence. ChatGPT as an app has the best executive presence I've ever seen of a chat app, right? It sounds like it knows exactly what it's talking about. And 90% of the time on initial run, it might be right. The problem is 90% for most use cases is simply not good enough for production. You have to get to at least some number of nines higher than 1. And getting to that requires a lot more nuance to be able to do this well, which is why everybody that actually is serious about this cares deeply about evals and cares deeply about the nuanced techniques it really takes to get this stuff right. And so, that's really kind of what I think one of the biggest challenges the industry is facing around this.
All right, and thanks for that, Aaron. Musa, you're in UBS in the financial services industry, which, in addition to getting it right, you also need to demonstrate that it is right to your regulators. So, can you talk a little bit about the challenges coming from a highly regulated industry?
Yeah, I think that is spot on. So we are not interested in evaluation of GenAI large language models just for the sake of assuring that they're working, and that's on its own is a very good and valid reason. But we have rules around what we can put in production. And actually, it's not a new phenomenon. Basel II, which was released in 2004, 20 years ago, was already, very clear on the monitoring needs, monitoring of the models. Back then, obviously, the focus one was on narrow AI. And then in 2011 with SR 11.7, which is really the foundation of model risk management, in banking, we went to the next level. So all the banks who are regulated, there are different regulation regimes depending, how big and how systematically relevant the bank is. For kind of top tier banks, let's say from a regulatory point of view, they have a very mature model risk monitoring systems, including UBS. Obviously, with the introduction of GenAI and large language models, it's a different paradigm, and there are challenges. I think we will discuss these challenges in the next hour or so. But the expectations are really clearly there, and we are not supposed to put any models in production that are not passing certain, I would say, quality assurance criteria.
Right, and you touched on SR 11-7, which talks about a number of sections around model evaluations, model monitoring, and as well as the development lifecycle of models. I think let me just briefly ask you one more thing. What is different about GenAI, Musa, than the previous generation of models? Like, what makes it, why can't we just do what we were doing before?
Yeah, I think the problem is twofold, right? So one is the complexity, right? So in the past, if you look at the Basel II and what people had in mind when they came up with these regulations, they mostly had narrow AI use cases, as I said in previously, and they were talking about a handful of parameters, right? So I worked as a quant for years. If I look at rating models that we were developing back then, we are talking about maybe 6, 7, 10 factors and 10 parameters, weights to understand how good an entity is to get certain credit, for example. Now, with ChatGPT, as you might already know, we are talking about 170 billion parameters, the version 3. Version 4 is said to be 10 times more. Nobody knows, but 1.6 trillion parameters. So we are not able to make sense of this. The second aspect, is the autonomy, right? So I think there is this trend, we're not there yet, for these GenAI models to become autonomous and to make decisions automatically. And I think this is creating a problem because that was not foreseen in the current regulations, right? And the problem really lies at the intersection of this complexity and autonomy, right? So we don't understand how these models are making decisions, and we are probably not that happy that these models, from a regulatory perspective, are making decisions that we don't understand and we cannot reason about. There are some legal issues, ethical issues, discrimination, you name it, a lot of challenges at this intersection precisely.
Yeah, absolutely. Thank you. So, Carlos, you're the engineer in the room. How do you solve this problem? So there are a couple of things that Musa touched on that you're dealing with. One of them, autonomy, and how do you actually evaluate at runtime is one of the things as well that you're looking at. So what are the tools available? What are the techniques available today that people can apply?
Yeah, so we've started slow. Like being NVIDIA and having access to a bunch of GPUs, the initial push to just train a model was really strong. People are really excited to just get on with a new model and start training from scratch. And we're already gathering data before I walked in and said, you know what, have you guys tried prompting? Just talking to like a standard already available model to see what it does. And the answer was like, no, that's not exciting. So in order to make that a little bit more exciting, we did a few demos. And then it became kind of clear that the approach we wanted to take was more of a was more like chiseling out the sculpture rather than building out the sculpture. So because the models, let's take GPT-4 as an example, right? It confidently states things that it doesn't necessarily know. It will produce output even when it shouldn't, but it sounds good when you don't really have a way to anchor it back to reality, or back to the facts that you wanted it to look into. So the first approach we took, and that's still what we're doing pretty much, is treating it as a black box and trying to constrain the outputs as much as we can and being very conservative in what we send it. So if you can't really know what's going on in a black box, then having a smaller impact on what that black box does is a good defensive strategy to start with. Then, of course, we bumped into a bunch of situations where that wasn't really enough. We wanted to have it do more. But instead of growing the available actions that we presented to that black box, we just built more black boxes. So we have a system of agents collaborating in a group chat rather than just one big agent that does or is prompted to do everything or to reason about everything. So there's a bit of RAG here and there. There's a bit of just prompt engineering. There's a lot of formatting work that we need to do. And those things are taken care of by different agents with different prompts, and they're evaluated differently. So we're almost at the level of trying to make the LLM work become unit testable, because the outputs are like sometimes just a handful of possible strings that we want out of them. So that becomes a little easier to work with. But yeah, we've deliberately decided not to do anything big tech, big like flashy tech for now. We're using PyUnit instead of any sort of eval framework. We're using things that you would be expected to just know coming in from knowing a bit of Python, or that you can be taught within a week, rather than any fancy tooling, really. And the approach has been paying off so far. We know that it's got some limitations. We'll probably discuss this at length, but so far so good.
Right, and so there's a couple of things that I understood from your approach is you're saying that instead of taking the LLM application as one big black box, you're breaking it up into smaller black boxes and putting eval loops around each of them. And then there's probably also a systemic test, if you want to call it that looks like across how the system is functioning, and you're essentially prompting and using one LLM to evaluate another in that context, and as well as some more deterministic tests that you make. You may be able to. It may be obvious by just looking at the thing that it should behave that way, that you can build up.
That's right. Thoughtworkers in the room will probably recognize this as a test pyramid. So we're doing the small black box tests in a much larger quantity than the tests that touch on multiple LLMs collaborating. And then finally, on top of that, there's like maybe a handful of tests that bring the whole thing together. Right.
So Cheyenne, you're researching this area, so you've obviously seen what's out there in the industry. So what are your thoughts on kind of the limitations, what's good, what are the limitations, and where to go from here in terms of those limitations?
Yeah, it's a good question. So just to sort of like put it out there, the science has still not really caught up. So what I mean by that is the kind of like industry standard approach to evals today is very much LLM as a judge for the output of another LLM, and you might have a human that's like kind of in that loop in some capacity. Pretty much every vendor that's out there is doing some shape of that, where you essentially have like a slider where, you know, either you trust the model more or you trust the model less and you want more human interaction or something like that. So it just depends on the implementation. That's kind of like the shape of every evals, you know, thing at the moment. There are a couple like issues with this, and I want to touch back on the earlier question around like, you know, what's changed between the previous generation of AI and this one. There are a couple like very practical differences that make a massive impact in the way we approach evals. So concretely, in kind of like the quote unquote yesteryears of AI, when we were all training, you know, like classical models, and, you know, we had our own classifiers and so on and so forth. Even if we were doing deep learning there, people would call it, oh, you've got a black box. But that black box was within your four walls, a network that you designed with data that you trained it on. So yeah, it's like hard-ish to explain exactly what that model is doing just by nature of its architecture, but you owned it. You could touch it, you could feel it, you could probe it, you could do anything you wanted with it because it lived within your four walls. These days, some aspect of that is removed. The vast majority of the market are using things like a GPT-4, like a Claude, like, you know, so on and so forth, where now the paradigm has shifted. Now I can no longer touch and feel this model. I interact with it via an API, and I have no control over when that model changes. So that adds like some very clear runtime issues, let alone, you know, test level, eval level issues. And then obviously there are the cases where you're running an open source model, or you've even trained, you know, fine-tuned one yourself. Most people are not training, you know, fully pre-trained bespoke LLMs these days. Typically you're building on top of something else, which then implies that you're inheriting a model that you had nothing to do with its training. You know, you don't know how it was trained. You don't know what data it was trained on, and so on. So fine-tuning that is also kind of like a complex beast in and of itself, you know, to avoid catastrophic forgetting and a whole bunch of other stuff. So tying this all back together, we have to now think about evals as this like kind of existential problem of, I have this thing that may live within my four walls, it may not, but I need to be able to interact with it and understand it in a fairly deep and sophisticated way. To Moose's point, like, we need to connect, not just is it working, but we need to connect, is it working with, is this appropriate from a regulatory perspective? Is this ready for production, which has a whole bunch of other things around it? We need to do that with what is now a true black box, something that may not live within my four walls, something that I did nothing to train it necessarily. And, you know, for a problem space where it's able to project into infinity, you know, with these classical models, oftentimes you were constraining the output space. You had like, you know, X classifications, you had, you know, X possible categories that something could fall into, or you knew the shape of the output ahead of time. Here, it's strings in, strings out, and you don't necessarily have a great deal of control in between. So there are all sorts of problems there. I would say that, like, in terms of what's coming next, and, you know, things are still very, very early here. Lots of folks have been doing similarity measures, obviously. So like from a unit testing perspective, it's like, I've got a known good input, a known good output. I run that against my LLM. I get some output. What was the similarity between the known good output and the output that my LLM gave me? But then you also have to consider like the temporal aspects of that. So like, perhaps it was only good at that point in time. Do I need to start doing cohort analysis? Do I need to start calculating kappa values of, you know, disagreement and a whole bunch of other stuff? So I would say that's like one trend line. And another trend line, which is where our interests are, is actually in kind of more of the fundamental math and science of it all. So we're taking, like, for instance, a geometric and topological approach to understanding high dimensional space. So using embedded text and exploiting properties of high dimensional space to understand a little bit more of the nuance in terms of how the output my LLM gave me relates to the space that I think is appropriate or, potentially dangerous and, that sort of thing.
Right. Awesome. So, Aaron, coming back to you, so Carlos and Cheyenne talked about kind of what exists today and what's potentially coming down the pike. How do you communicate this back to whoever needs to finally approve that this thing is ready to go, ready to be in production, or you have to justify to yourself? What other types of questions would you ask? So for example, Carlos has built a test pyramid. Say, hey, has it checked for this? Does it do this? Like, how do you then interrogate the output of what Cheyenne and Carlos talked about in order to validate whether that is good enough for you or not?
Right. I mean, so part of it, you have to show just kind of the data about how much more accurate it's getting over time. So say you're doing a reinforcement learning approach where you're taking, in any one agent in the model, even in a multi-agent framework, how much, say you have 100 questions, and, kind of technique we use is I like to start with like an easy question and have it, question 100, have it be a really, really hard question. And you want to see over time, as you do whatever kind of prompt engineering or fine tuning or anything else you're doing in the model, you want to see that increase over time. And you want to see these good faith efforts towards making the model clearly improving. So that's part of it. The other part of it is we have to be honest with ourselves and not try to sell these as deterministic systems. And I know everybody in the room probably knows this, right? We all know these are not deterministic systems. Anybody telling you that is lying to you. They're probabilistic systems. We just have to accept that. And how accurate it is, knowing that even deterministic systems aren't always 100% accurate. We still have software bugs, right? So the threshold of what is correct isn't always 100% anyway, even in the old way that we did it. But I also think we have to compare it against our baseline. So, when people talk about self-driving cars, they're not saying it has to be 100%. It has to be better than humans. So if an autonomous system is making decisions, one of the first things you're going to do is always have a human in the loop. As it starts to get better and better and better, you only get to full autonomy once you've been able to validate that it's at a threshold better enough than humans, that the broad consensus of people around you believe that's okay, and that kind of risk that you have is something you're willing to accept. But to say any system like this can be riskless is a fantasy and does not exist. Nobody should be selling that.
Right. And of course, Musa, in financial services industry, risk is what you deal with all day in general. And so how do you see the difference between the deterministic and non-deterministic natures of these things in terms of are the regulators, the regulations really able to handle kind of that nuance, and as well as the nuance between kind of the new capabilities that AI offers versus traditionally what humans have been doing? And how do regulations kind of see that world?
Probably not at this stage, right? So I heard the other day that 37 countries are working on AI, GenAI regulations. I think the general understanding or tendency of these regulations is probably similar, but the details are very different. If you look at the US executive order that was published a couple of months ago, and compare it, for example, to EU Act, AI Act, the way the regulators are planning to handle AI is completely different, right? What I want to say, and maybe probably I'm joining Aaron and Cheyenne here, we went from a world where determinism and explainability were given to a world where the only thing that we can do is to interpret. We had access to the models. We could really explain how these models were working, the inner working of these models. If you have 10 weights, you can do that, right? Now we can't, and we just need to here, and we have this black box, and we are trying to interpret, make sense, of the output, and it's kind of different world, in my opinion. the difference, maybe there are another differences in the past, even though, maybe the general public didn't know how things were working, you could find some experts who could explain to you how things were working. Now with GenAI and large language models, even top-notch researchers, maybe they are not publishing everything, I don't know that, but from what I can see, they don't even understand what's going on. It's working, it's magical. Honestly, it is magical, but there is no kind of sense of why, in details it works. And then for a bank, regulated bank, I think it's very difficult to use these auto magical things. You are dealing with clients. The number one capital of a bank is the trust. And I think the bank is, or we are trying to do everything in our power to kind of, preserve this trust. Right. If you look at what has happened over the last year, some bank runs, it was mainly due to the fact that people lost trust in the banks, and we don't want to, at this stage, put, for example, a chatbot in front of the clients, because this might lead to, certain issues in terms of discrimination, bias, and hallucinations.
Right, absolutely. I think you brought up interesting points in terms of how do you know what exactly is happening. I'm thinking there's one thing from what we're talking about in terms of evaluating whether the output is good. Yes, the output is good. Let's say that the output is like Aaron said, maybe not 90% good, but 99.9% good. Congratulations. But a lot of the times, from a regulatory perspective, as well as from just like an executive perspective, you're trying to ask, how did it get to that? How can I trust that that's always going to be there? So, and how did it kind of get to that point? So, so let me start with Carlos. How are you achieving getting a little bit more insight and visibility into what the application is actually doing?
So we started by decomposing the problem into multiple collaborating agents, and each agent has access to its own LLM. We did that also because it can be cheaper in the long run. We started using larger models like GPT-4 and Claude, and now we're at the point where we can look at some of these agents and say, you know what, a little LLM for this, a small llama would probably do a good job here because it's a binary decision that it has to make, or it's just choosing out of a handful of possible choices. We can prompt that a little differently and run it through a smaller LLM, save a little bit of money, make it faster. I don't know, there's a bunch of potential benefits there. But the way we're trying to make the problem smaller, or trying to subdivide the problem into smaller problems, is just having the LLMs be used in the smaller black boxes instead. I mean, our problem set is nowhere near ethical decisions. We're mostly controlling supply, demand, and observability data for GPUs. Thankfully, we don't really have to think too hard about those kinds of problems. Would not want to be in Moose's shoes right now, because it gets a lot more complicated if you have to add interpretability to these decisions, right? So we're kind of treating LLMs, or we're applying LLMs to situations where that's not really a problem. That's
one thing I'd add to that too.
Skirted the whole thing.
Yeah. One thing I can add to that is a lot of the work we do. So a little bit of the inside baseball is we do a lot of work where we generate code from one LLM, then runs in kind of source databases that then gathers data from telemetry or other things that are interesting to us as we manage GPU fleet. And so if you're doing code generation, you get to see at least the artifacts. You can get a little bit of the trust because you show users the code that's actually being generated. It generates the SQL and then puts the information back in the context window, which gives you a little bit better ground truth when you're doing this. So you're actually doing rapid data from real databases. At the same time, you can see how it's generated. But it still isn't perfect, because hilariously, I remember I did this experiment before I joined NVIDIA, in fact, over a year ago, where I asked a system to say, please help me figure out the average salary for women in this company. I was building an LLM that worked over an HR system. And if it didn't have a gender field, it just said, oh, if the name ends in A, like it would generate code that would show if the name ends in A, it must be a woman, which is hilariously bad, but also, kind of, the benefit of that though, is at least when you're generating code, you can kind of examine it and get some explainability. Oh, this is why I made this terrible decision. And so maybe that might be one kind of tip people can use to think about this. It's almost better if you're generating code because at least it kind of shows you the thinking in how it's generating the result.
Right. That makes sense. So Shan, going from smaller black boxes, and kind of using code as an intermediary language so that you can kind of inspect each step individually. What if we want to see kind of what's potentially happening inside the black box to a little bit, to whatever degree it's possible, given that you don't, as you mentioned earlier, you're going outside your walls, you're not talking to your own model. Any other ways to get some insights deeper into the black box?
Yes. So first, I also want to mention that we have a couple questions that have all cropped up, and I think they all touch this particular topic. So I'm going to knock them all out in one go. See if you can get a 3-for-1 type of thing. So first question is, what are some of the risks with only being able to interact with the AI through an API, as mentioned, and having no control of models changing? And what are some ways that could be controlled, monitored, or mitigate this? We have another question, which is, what is the biggest challenge enterprises will face implementing LLM evals at scale, cost, design, engineering, etc.? And finally, what aspects of observability are critical to establish trust? Is it how the AI decides, or is the visibility into how the output is generated, or is it what content is the model trained on, or is it the bias and ethical aspects? So all touching on roughly the same thing here. So first, let's talk about like the nature of the black box, right? So again, this is, I think for the first time, like people have been talking about like the black box of AI for a really long time. This is the first time where it's actually a black box where like we are not allowed to touch it. So I think that's like kind of an interesting thing there. There's some dangers along with that. So like the practical dangers are obviously everything we've talked about so far, risk and, just not being able to interpret what it's doing and requiring a human to evaluate it and, so on. And I think, the direction that Carlos and Aaron are taking is absolutely correct, in a pragmatic sense, which is just like, I need to be able to audit what the model is doing. So what do? I try and get it to generate some output that is itself auditable. And what is more auditable than code? I think that is a very practical way to approach this. There are a couple like dangers though that need to be thought about, maybe not addressed immediately, but, thought about. One is vendor lock-in. As you are creating more and more prompts, essentially, like if we're being very practical here, like fundamentally you have a bunch of prompts that drive the application and you have a bunch of prompts that evaluate the sort of processes that are within that. The side effect is that you end up having to write prompts in a specific flavor of language that that model seems to adhere to. So like a prompt for GPT-4 will work one way. If you just copy and paste that same exact prompt into Claude, you'll get a different output. It might not be radically different, but it might not have the properties that you so carefully tuned for GPT-4, which means that as you increase the surface area of your LLM application, as it does more stuff, and as you have to test more stuff, you are now at risk in a very real way of complete vendor lock-in. It's very difficult then to just like rip and replace that and swap it in for a new model. So let's say that you decided to do this POC or something with a model that's easy, like GPT-4 or something. You're interacting with it via an API. Everything's all well and good. And then you realize from a regulatory perspective, it's actually very important that you're using an open source model or something that can run within your four walls. Now it's not a linear motion to then like get that model inside of your four walls and just copy and paste everything and away you go. You have to like recraft a whole bunch of stuff almost from scratch. So that's like fundamentally problematic. Now, on the topic of like dealing with models changing and stuff, that's another thing you have to contend with if you're using a model that you're accessing via an API. oftentimes it'll change and you won't know that it changed. You'll suddenly see some different behavior. So I think there are some practical recommendations here. This is very similar to drift monitoring in classical machine learning. The only difference is that now you have two different variables you have to track. In the previous world, you kind of assumed that your model will continue working in the way that it has, so that distribution is fixed. And you assume that there's some data drift, that it's not the model itself that's drifting, it's users or the data or the environment itself is drifting. And you use that as an indication when you want to retrain your model. In this case, you actually have to track two drifting distributions. So it becomes more complicated, but it's not intractably so. Something that's like one thing. So basically, like the concrete answer to the first question is very much just like, you're going to have to do some drift monitoring on both sides. You're going to have to do it on the data side, basically the input side. You're going to have to do it on the model side. And you're basically going to have to just pay attention to those distributions. Now, the question is, what do those distributions look like? And that is a much harder question to answer because, again, the science is not caught up yet. In a perfect world, there's a concrete set of metrics that you can calculate that give you the full perspective of like, here's how my application is working, and here's its reliability, and here are the ways that it'll hallucinate, and you can track those metrics over time. And it's easy, but those metrics don't yet exist. That's part of the research. So that's one element. Now, Prasanna, to your actual question, which is like, what can we do? It's so again, like this is all very, very new stuff. I think from a practical perspective, the answer is do exactly what Carlos and team are doing, which is break it down into smaller pieces that can more easily be interacted with by humans. That is the best, most consistent way today. But again, that's not sustainable, especially as we're thinking about like the aspirations of Gen AI. Everyone is talking about agents right now. Just in this one conversation, we talked multiple times about agents. Yet I haven't seen an actual, what I would consider a true agent in production. And that's not me gatekeeping the definition of an agent. It's just, we have these aspirations of what an agent can do. It's meant to be autonomous. It's meant to just go off and do its thing and come back with the right answer. But we can't even trust it to do one iteration by itself. We have to have a human in the loop to like give it an input, get an output, and then audit it. That's impractical if an agent is going to do like 18 such actions before it actually performs the task. So mechanically, what we can do is we can find ways to provide interstitial metrics that can be injected back into the model in various ways, either back through the context window or otherwise controlled within the model architecture itself. So some promising techniques are things like structured decoding, for instance, or constrained decoding, where this is going a little bit into the weeds, but I promise it's worth it. If you think about an LLM, you've got basically two primary flavors. You've got decoder-only models. So that's like a GPT, that's a llama, kind of the flavor of the month type models. Those are decoder only. And you can kind of think of it as just like it takes in text, it gives back text, and that's pretty much the whole thing. In between, what it does is when you give it some text, it conditions a whole probability field across its entire vocabulary to then rebuild possible outputs. But the reason why it's non-deterministic is because you actually have to sample from that field. It's not that there's one singular answer all the time for a given input. Even if the model doesn't change, the vocabulary is so huge, and there are different ways that you can interpret the best possible path through that field, that as a side effect, you get several possible answers that are all equally valid in the mind of the decoding algorithm. So oftentimes that decoding algorithm are things like beam search or nucleus sampling or what have you. But the idea behind constrained decoding is that you can change the way the decoding happens to introduce information that you actually have ground truth about. So take, for instance, like if we have an example where an agent is meant to use an outside system and it's meant to interact like a database or something like that. Even if I inject that information directly into the context window, I have no guarantee that that information is going to be chosen as part of the decoding path, right? It could hallucinate. Like maybe I ask, how many active GPUs do I currently have? And the right answer is like 113 or something like that. And then I go and I put that into the context window. The model might say, oh, you got like 86, just because that happens to be the token with the highest probability, and you have no way to interpret that in between. So instead, with constrained decoding, what you can do is you can say at decoding time, yes, the model has all these various probabilities that have been learned and approximated and conditioned across the entire vocabulary. Using this outside information, I can go in and manually change the probability of the token 113 and make it artificially huge, just because I know that's the answer. So then I change the potentially optimal path through constructing that output, and then I can almost guarantee that it will always say that I have 113 GPUs. It might frame it differently because the English around it might be, it's up to its discretion, or, whatever the context window says. But that is one such way where you can actually start eliminating, or maybe not fully eliminating, but controlling things like hallucination. But again, that implies that you are willing to go in and, change architectural aspects of the model, or that implies that there are interfaces for you to be able to do that, which obviously there aren't if you're using an API-based like vendored model. Now we're starting to move into like open source territory. That's like one major area. And the second major area I would say is that there's a lot of research being done around, again, like the topological and geometric aspects of this sort of thing. I say a lot of research. I've seen like a couple papers in the last like 6 months. It's gaining some traction. But I'm pretty convinced that is like the currently most viable approach to some of this stuff, where you can use the embedding space as an approximation of what the model is likely trying to do under the hood. So you can use the relationships between your inputs and your outputs in embedding space and kind of like use topological analysis to figure out like, okay, this is probably the space of things that are appropriate responses to my input. These are the things that I think are okay for the model to say. And these are the spaces of things that are dangerous. So if I see an output that's anywhere close to those spaces, I just don't even want to show it to a user. I want the LLM to retry, right? So now we're getting closer to a world where the LLM itself or the application harness around the LLM can start working independently of a human. That's when we actually start having some confidence and reliability, because I know that we went in and we changed the way these outputs are getting decoded. We know that ground truth is being inserted in a way that we couldn't otherwise control from a context window perspective. And I have a system in place that gives me some sense of like, I've gone in and I've defined the space of things that are acceptable without having to use regexes, keywords, things where like the model can be really, really creative in the way that it circumvents my guardrails. So I need higher level guardrails to be able to do some of that stuff, which again comes back to just like a fundamental analysis at like a geometric level. So yeah, that's where the research currently is. But again, that's scratching the very tip of the iceberg at the moment.
Right, absolutely. So I'll go to Musa next. And coming from a financial services regulatory framework perspective, would these, like, I understand this is a bit of a speculative question because what Shahan talked about is kind of research direction, which isn't necessarily done. And maybe there's an answer there, maybe there's not. We'll see, as things go. Are these things helping in being able to, rather moving in the direction where you can satisfactorily satisfy the regulations, or maybe help the regulations evolve in a direction that is kind of appropriate for where the technology is and where the industry is? So, for example, understanding which manifolds, for lack of a better word, which subspaces in the overall embedding space are safe and which ones are dangerous, and bringing in guardrails to move you in the better direction, bringing in, as Shan talked about, other retrieval steps in the middle of the decoding in order to make and ground the response to very specific numbers. Because in financial services, or in GPU allocation for that matter, you better get that number right. Otherwise, the markets are moving in either case. So Musa, do you think these types of approaches are heading in the right direction, or are there other directions that you see that are yet unanswered or unexplored that you would like to see movement in?
Yeah, I think at the end of the day, it's a balancing act, right? So we have the pressure from the market forces to use these models, right, to reap the benefits, and at the same time, we have the pressure from the regulators to be cautious and not maybe to go too fast, right? So we need to balance the two. I don't know if there will be a kind of final answer. It's, as Cheyenne said, a very, active area, research area. What I can say is it's maybe the first time I see regulators asking, to collaborate with the industry players to come to a common understanding. I mean, let's face it, they're in the same boat as we are, and there are also kind of just some geopolitical aspects here. You don't want to appear as a regulator that is killing the innovation, but at the same time, you want to be prudent. So what I see is many regulators discussing with the industry players, as I said, to come to a common understanding. Maybe we cannot solve everything, but to come up with kind of general understanding of cases that are solvable, that we can say low risk, and cases where we still need to do some additional work. So if we look a little bit, and I'm going to oversimplify here, if the output of an LLM is a categorical variable, we can use the classical, performance metrics like accuracy, precision, recall, and whatnot, right? If the output of an LLM has a reference data set, question answering, for example, or retrieval augmented generation, where you can check, if the model output is working or in line with the reference data set. That is, I think, also something that we can live with. Where there's a problem is it's kind of free output. There is kind of no constraint, like take some sort of summarization, right? So how do we know kind of the summary is grounded, is accurate, it's not hallucinated, etc., etc. And I kind of feel that we need to do a lot of work there, but I also think it's a kind of really hard because, as you might already know, hallucinations is an inherent, for example, problem. It's like the way the large language models are trained is basically to hallucinate, right? So we cannot really, make them disappear. I think we need to find means to control that. And one thing I was thinking about, I don't know if the research is going into that direction, is I think we need to kind of combine this free nature of large language models with maybe something that is able to kind of plan. If you kind of see, and Cheyenne has discussed a little bit that the probabilities and paths across this, as a kind of through this forest of words, how do we know which path is optimal given certain criteria, right? And I think to be able to do that, you need maybe something else which is not available right now. I mean, one example I've seen where this is used is to combine a large language model with a mathematical solver, So the LLM was generating hypotheses, and then you had a mathematical solver which was checking this, hypothesis to pick the right one, and then evolving the process, right? So I mean, this points into the direction of maybe reinforcement learning, or something that is able to kind of weed out things that cannot work or should not work, right? Again, I think it's an active research area, and we should wait and see, what comes. But that doesn't mean that there are no instances where we can't use large language models right now in the back, right? As I said, we are a little bit reluctant for client-facing chatbots, right? Where you can have kind of free input, free output, right? But internally, we have a lot of use cases where we can use where this reputational risk is kind of, much less of an issue, and it's already adding a lot of value. In UBS, I think we have a couple of hundred proof of concepts already people are working on, and probably 10 plus 20 cases that are already in production.
Nice.
Yeah.
So what you're saying, Musa, is I shouldn't just use ChatGPT as my financial advisor, just like dump in my financial statement and get some recommendations of some stocks to buy. That's not the approach I should take yet.
No, I mean, I think I wouldn't suggest to burn your house and put everything in a ChatGPT recommendation. But as a kind of supplementary information, why not? I don't have anything against it, right? I always thought you should invest in things that deeply. But
that's why my entire portfolio is in VOO, but that's a whole other conversation.
Don't do that. Don't do that. That's never a good thing.
Yeah. Let me ask this one question. I think Musa, you touched on it briefly, but I wonder if anybody else also wants to get on that. One risk mitigation strategy really is make it internal, right? And I think, but the other one also is to the challenge is that the UI is too open-ended in the sense that you can just copy paste anything into that thing or inject any kind of a prompt. So is there a way from a UI perspective to kind of constrain the input and the output or other techniques to make LLMs useful in a particular context, as opposed to kind of general purpose, can answer any question in the world? Are there any UI elements that anybody is seeing that are working well? Aaron?
There you go.
No.
No, so one thing I can talk about is, so we have an engine that we use to answer questions about GPU telemetry. And we explicitly show all the code that it's using. We don't try to hide it. Like in ChatGPT, if you try to ask it to use the analyzer for a code, you can kind of see it, but you have to press a button to get it. And I think further down the line, maybe that's what you do. We're very explicit about showing the code that's being generated on the path to generate the right answer. And at least that gives a little bit of explainability. It's not explaining how it generated the code, right? It's not telling you the paths within the model that did the code gen itself. But at the very least, especially because it's a multi-step system, where we're generating code, putting context, and then generating more code on that, and then multiple steps, it at least gives us an ability to not only do explainability, but we also ask our users, was this right in any given one of these steps? And for people to go through and evaluate it, actually helps us improve the model to see how it can generate better code.
All right.
Yeah.
Awesome. So
we're also not necessarily treating everything as human input, right? In some aspects, the input is the running systems. So there's fewer questions that the users can ask, and more like, given this current state of the system, can you show the user what's interesting about it? Right. So not everything has to be a chatbot, right?
Right. Yeah, absolutely. And as we're heading towards the end, let me just touch on Chris Kramer's question once again. It's in the answer section. Aaron, do you want to take a crack at that as well? I know we answered it a little bit.
Yeah.
But I wonder what your lens is on that. The question is, what is the biggest challenge enterprises will face implementing LLM evals at scale? Cost, design, engineering, etc.
Right. So the cost element, you're going to spend some tokens if you're trying to use an LLM to judge another LLM. I think you shouldn't worry about that. You might spend a couple $1,000s on ChatGPT or whatever LLM you're using. I think that's a very virtuous use of money for that, and I wouldn't question that much at all. I think getting a good design around this, kind of leveling up from, okay, we have a unit test, we're using one GPT model to judge another. I think that's a good first step, and you should just try it that way. As you evolve it, I think, the biggest thing is, how do you get a good set of questions that are relevant? How do you get confidence in it? I think that's certainly not the hardest thing. I think the challenges become on the engineering side, and this is not that different. It is different in some qualities, but at the high level, it's really not, than designing kind of a more traditional microservice architecture, at least the way we do it in a agentic system where we have multiple agents talking to each other. I think being able able to do evals at that level, you're going to borrow from a lot of techniques that you might have borrowed, done in, like we said, building a test pyramid for your LLMs. If you have a structure of multiple LLMs, it's a nascent technique, but it's something that we're finding success with. But I think the best way to frame this is almost everybody is creating this now. So be prepared for inventing things, because there's not a lot of fire material out there about how to do this well. And even at NVIDIA, where there's probably maybe 8 or 9 projects like ours across the entire company that are doing these kinds of agentic systems. We're collaborating and sharing knowledge even within our walls about this. So we're still kind of in the very earliest phases of how this is meeting the industry. And I think that's where some of the biggest challenges about how do you eval these kind of groups of agents that work together. Frankly, borrowing from a lot of industrial organizational psychology as much as anything else. Like, how do these things talk to each other? Are there ways that we can understand and evaluate how these multiple LLMs actually have conversations?
All right. So let me wrap up as we get to the time. I believe everybody's going to get dropped automatically at the hour. So I'll just conclude us real quick. What I understood from this conversation is that evals is very important before you're able to get AIs into production. Maybe there's some risk mitigation strategies you can do in terms of keeping it internal and all of those things. But ultimately, before all the things that we dream about that, hey, LLMs and GenAI is going to solve these problems, whether it's agentic workflows or direct-to-customer, customer-facing kind of applications, there's a big element of evals that's going to be important. Second aspect is that some of these problems are not solved. So it's not so much that you don't know how to do it necessarily, but it's just that nobody knows how to do it. So it's a matter of some things that are yet to come out. But the third one, I think that's also important, is that there are enough things out there today that you can start on that journey. And it's not so much that you have to just wait for all of these things to uncover. There's value to be had. There are reasonable mitigations to put in place. Yes, there are some challenges, but there's no reason to stop. And I think the key thing here that I'm also reflecting on is that it's not like the 200,000 tokens thing that Aaron talked about. Is that when it comes to planning and budgeting around your LLM initiatives, especially across an industry, I think one of the questions is, have you allocated the right time and money into specifically evals and specifically taking kind of a defensive approach? Especially as you think about it in a platform. And from a Thoughtworks perspective, I think as we build these LLM platforms, this is one of the services we're starting to offer to clients, is kind of building evals as a thing, as a part of their overall AI platform. I think that's something that you'll see some more stuff on. But I think that to me is a trend that I'm observing, is that while there are things, it is not sufficiently emphasized in these things, because right now people are just happy seeing the demo and kind of getting excited about it. But I think there are some challenges coming up next. I think that's all we have. Han, I think you wanted to show us the picture, or maybe we'll send it out at the end to everyone. Is that right? Can we zoom into that, or is that going to happen only afterwards?
Might happen afterwards, I think.
All right. Thank you very much, Han. That looks really interesting. I need to zoom in to read all of that. Thank you all for joining us. I think this is just, first of probably many conversations around LLM evals. We think this is a very crucial thing for the industry as a whole to get right. Otherwise, we're looking at another AI winter, essentially. So that's it. Thank you all. Bye.